Okay, so here's where we left off. And we said that, well, we had just got done talking about color and things like that, but now we're talking about mirrors and reflective surfaces. And the first kind of mirror is pretty much the plane mirror. And when I say plane, I'm not talking about PLAIN like yogurt. I'm talking about PLANE, which means flat. So a plane mirror is a flat reflective surface that produces a virtual image, an upright image of the same thing. So notice you got this mouse, it's looking at its image, it's upright, it's a virtual image, and it's the same size. Here's kind of a diagram of how this works. You can see that this particular lady, she's looking downwards, and the reflection is actually of her feet, but it makes it appear as if she is equally far away from the mirror, giving her the sense of depth that her feet are actually on the other side, which of course is not true. Her feet are right where her feet are. She's just looking at a reflection. Speaking of reflections, isn't there a song about reflections and that guy? Anyway, let's move on. Mirrors. There's three major types of mirrors. We already discovered plane mirrors. The next type of mirror that we should discuss is a concave mirror. Sorry, I was eating a Twix bar and something foreign got in there. But there's a concave mirror. A concave mirror is a mirror with a surface that caves inward, like the surface of a bowl or the inside of a spoon. It reflects light waves to a focal point. So take a look at our diagram down here. Here is the concaveness of a concave mirror. And let's just look at one particular beam of light, for example. This beam of light is hitting the bottom of the concave mirror, and because the concave mirror at this point is angled, is bouncing the light up. If we look at this beam of light from the top, it hits an angled surface and it bounces down. The place where all the light rays meet together is called the focal point. Now, I think there's let's see here. In this particular picture right here, the candle is beyond the focal point. You might say, how can you tell that the candle's beyond the focal point? Well, stop. Look, if we have this image, let's just suppose that this is the bottom of the candle. The image of the bottom of the candle hits here and goes up, and we go past the focal point. That image of the bottom of the candle is going to appear up here. And if we have this top image right here of the top part of the candle, and it's hitting this edge and it's bouncing down, then it's going to flip the whole thing completely upside down. So if you're beyond the focal point, whatever you see is going to be upside down. But if you're within the focal point, everything you see is going to be right side up. So look at this candle right here. It's upside down. So we know that this image of this candle is beyond the focal point. It's upside down. This candle is within the focal point. It is right side up. It appears slightly larger. So here's the question. In this satellite dish, where's the focal point in the satellite dish? Well, it's not rocket science. The satellite dish acts like a giant concave mirror, so any radio signal that hits it bounces off of this, since it's curved, reflects all those radio signals to one point. This little black dot is the actual receiver, not the entire dish, just that black dot. And the black dot is positioned at the focal point. So this is like a giant collector, and it collects all the radio waves and focuses them right on the focal point, which makes sense. There's another type of mirror. The next type of mirror is a convex mirror. Let me see, where can I put myself? A convex mirror is a mirror with a surface that curves outward, like the surface of a bow. In this case, take a look at these images. If you have some source of light hitting the convex mirror, it's going to actually bounce outward in all direction. Convex mirrors are used in like hallways and things like that to see around corners, and since they're bent outwards, you actually have a larger field of view. It reflects light outward but produces a virtual image, but it's a smaller image of the object. Have you ever noticed that if you look in your rear view mirror is actually slightly, very slightly convex. And it says the objects in the mirror are larger than they appear. Well, that's because it's slightly convex. So you see this image right here. There's a person walking in a hallway, and the image is slightly smaller because the light that's hitting it actually makes the image smaller. I'm trying to think of a better way to say that, but look at this candle right here. Here's a convex mirror, and look at the image of the candle. Is the image of the candle bigger than the actual candle, or is it smaller? It's smaller. So it's a virtual image because it's right side up, and it's smaller. So that's what happens with a convex mirror. I may ask you a question about a convex mirror versus a concave mirror on your test. So you might want to pause for a second, watch this video about convex and concave mirrors, and we'll return here in just a second. Okay, a second has passed. Let's go on to our next slide. Next, since we've talked about reflective surfaces, now let's talk about surfaces that are not reflective, but instead are translucent or transparent, and those are lenses. So a concave lens is thinner at the center and only produces a virtual image. It's sometimes used in eyeglasses. We don't use concave lenses a whole lot, but look, here's the surface of the lens. It's concave because it's caved inward. I was going to show you something, a demonstration on the board behind me about convex images, or convex lenses, but I actually lent that out to someone, so I apologize. But what I was going to show you is this, exactly what you're seeing right here. You can see the light, it hits here, and when it's hitting this bent portion of the convex lens, it's actually scattering the light out larger. And it hits this particular portion and it scatters the light out larger. But take a look, once it hits the actual dead center of the lens, it doesn't really bend it in any particular direction. Whoops, let's go back here for a second. I'm letting you know on a test, you're going to see an image like this. Either this one or a convex lens. So it's either going to be a concave lens or a convex lens. And you'll see something like that on the test. And you need to be able to tell me what the light rays are going to do as they pass through it. Do the light rays come together or do they spread out? Well, with this concave lens, the light rays spread out. Now let's go to a convex lens. Here's the crazy fun thing about a convex lens. We have them in our eyes. A convex lens is thicker at the center and causes light rays to meet. I used the wrong word, meet. My bad. Whoops. It causes them to meet at a focal point. And I'm sorry, this kid burning ants with a magnifying glass is covering up what I wanted to say. But this kid is using a convex lens. And this convex lens, it's kind of bulged on the outside, like what you'd see right here. And it actually focuses the light on this one spot. So this kid is burning ants or something, I don't know, by focusing light on one particular spot. Convex lenses are used in lots of optical equipment. Cameras, telescopes, microscopes, things like that. And like I said, even our eye has one of these things. But let's look at the diagram. The diagram shows the light entering this convex lens up here. And then since it's thin and it's curved at this spot, it actually bends the light downward. And if you look at the bottom half, you can see that it's actually bending the light upward. And it's actually producing a focal point at the other end. And you might be thinking to yourself, Mr. Wagner, you said these were in our eyes. And if there's a focal point, that means everything that we see is upside down. That's correct. It's not that the world that we see is upside down. We see it upside down, and our brain flips it right side up. There's a really cool documentary on light and eyes that, I think National Geographic put out. And a guy wore these special goggles that had little mirrors in it that flipped his whole world upside down. After wearing these goggles for about 2 weeks, seeing everything upside down for 2 weeks, his brain started to flip it right back, right side up again. Your brain is the part that flips the image into what it should be. So essentially, our eyeballs see everything upside down, which is crazy to think about. So imagine like an image of a stick figure over here. The head is on the top, the feet are on the bottom, and there is light reflecting off of the stick figure. The light goes through this lens and then goes down. Remember, the top bar is the image of the stick figure's head. And then if we go down here, the stick figure's head is now at the bottom. The stick figure's feet are now at the top. So it flips every image completely upside down. And that's what convex lenses do. So remember, it's a concave mirror that has a focal point, but it's a convex lens, convex lens that has a focal point. So they're the opposites. And because it's got that focal point here, we can focus all the light in one spot. And if you took apart a telescope or a microscope or something like that, you'd see all those types of lenses. Well, okay, that's the end of the second recording. And hopefully that works out really well for you. Because we did this recording, we're able to skip a day, especially just before Thanksgiving break. And this makes up for, we were actually behind a little bit, but this makes up for it. So if you have any questions, go ahead and email me, and I'll do my best to respond to you as soon as possible. Thanks. Bye.